In this example problem, we are given two force vectors. We want to find the magnitude and direction angles for the resultant force acting at the origin. Force A is 500 pounds. Its direction is defined by two direction angles, alpha and gamma. Force B has a magnitude of 400 pounds. It is located in the xz plane, and its direction is given by the 5, 12, 13 triangle. I have set up my engineering paper to solve this problem. I am going to begin by finding the third direction angle, that is beta A. I will use the direction angle identity to find it. I rewrite the identity to solve for the cosine of beta. I find that beta is equal to 0.7461. Because it is squared in the equation, this number could be either positive or negative. Solving for beta using the positive value, I get 41.75 degrees. Using the negative value, I get 138.25 degrees. One of those is correct. By looking at our image, we can determine by inspection that 41.75 is the correct value. Next, I'm going to write force A in Cartesian vector notation. Multiplying the 500-pound magnitude through, I get my I, j, and k components for the vector. Now I'm going to do the same for force vector B. Force vector B lies in the xz plane, so its j component will be 0. I will use the 5, 12, 13 triangle to get the I and k components. The I component will be the x dimension of the triangle, 12, over the hypotenuse, 13. The k component will be the vertical side length, 5, divided by the hypotenuse, 13. And the magnitude is 400 pounds. And now I have my force B vector in Cartesian notation. We find our resultant force vector by summing forces A and B. I sum them by adding the I components of both vectors, the j components of both vectors, and the k components of both vectors. And now I have my resultant force vector in Cartesian notation. I use the Pythagorean theorem to find the magnitude of the resultant force. It is 787.7 pounds, or 788 pounds to 3 significant digits. And that is our first answer. Next we will get our direction angles alpha, beta, and gamma for the resultant force. The cosine of alpha is equal to the I component of our force vector divided by the magnitude. The cosine of beta is the j component divided by the magnitude, and the cosine of gamma is the k component divided by the magnitude. Solving for our angles, I get values for alpha, beta, and gamma of the resultant force. And our problem is complete.